Good evening, everybody. Welcome to tonight's edition of Shop Talk, hosted by the Triangle Area SQL Server Users Group. So as always, with Shop Talk, you may or may not have questions. We possibly have answers. We'll meet in the middle and either have questions and answers or not. It's sort of a Schrodinger show. With me, as often is the case, over that way, we have Mala Mahadevan. How you doing, Mala?
Good evening, everyone. Doing all right.
Excellent. And it has been a few weeks. Last time around was 4th of July, so we were busy blowing things up and or smoking meats. Depends. A little bit of column A, a little bit of column B. But we're back now, right in the middle of July. Welcome in, Anders. Good to see you. And we've got a couple of topics for tonight, but as always, the whole idea of Shop Talk is kick back and relax a little bit after a possibly stressful Monday. So we'll talk shop, so to speak. If you have technical questions, SQL Server related questions, data platform questions, hit us up in chat here and we'll talk about them. So the first thing that I do want to mention tonight is Past Summit. Past Summit did announce the lineup for speakers, but not the schedules yet. So the actual schedule of sessions, that's going to come out in a little bit, but at least we know who's speaking. And Mala, I believe you've got some link you want to drop in chat.
Yes, give me 1 second. I will do that.
So all right.
The lineup is out. They don't have the schedule yet, but I would think a speaker lineup is enough for people who are interested to consider signing up. If that's what you want to do, they do have a virtual option and they do have an in-person summit too. So here it is.
That is true. And if you want, there is, I believe it is still active, a discount code Azure175, save $175 off of your registration. So this is a paid conference. It will happen in Seattle, Washington, November 15th through the 18th. And there are a couple days of pre-cons. There are a few days of presentations. And then everybody goes home. So a lot of people will be speaking. Many of those sessions will be virtual. I actually will pre-record mine. I'm part of a learning path on Azure Data Engineering. And I'm going to put probably more hours into this one talk and specifically this recording and editing than any other talk I've ever given and probably any other talk I ever will give, because this will be, I'm not going to spoil anything, but basically this is like the wolf who drank nitroglycerin in the Looney Tunes cartoon. It's a thing that's going to be amazing, but you can only do it once. Except that I will not blow myself up. So I guess not like the wolf in the Looney Tunes cartoon. Anders says, only lost a few servers the last couple of weeks. That's good. That's good. Servers, they're like cattle. Sometimes you just got to call the herd. So our two main topics for tonight, unless of course chat, you get us off the rails. Frankly, I don't even know why we have Rails at this point. If we're just going to get off of them all the time. But they kind of are in Azure. Redeploy and back. Yeah, actually, thank you for getting me off the Rails already. This may be the earliest off the Rails moment. But that's okay because don't have too many things on the agenda tonight. So, in case you're not familiar with the comment, servers can be pets. Servers can be livestock. Pets and cattle. A server that's a pet, that's a server that you've custom built. You've spent a whole lot of time manually configuring things. You take care of it. You have to feed it, maintain it. You feel really bad when this thing goes down. Cattle, you raise those things for a specific purpose, and we all know what that purpose is. They exist in order to serve some purpose. You try to put as little emotional effort into the server as possible, because at some point you're going to get rid of it and probably replace it with something else. The whole idea is getting servers to be more like cattle, less like pets. That saves a lot of time in the long run because servers do fail. You do have to do upgrades. You do have to do replacements. Things can happen such that you'll need to build another server. And how you get something from pet to cattle is typically going to be automating processes. I need to deploy these config files. I need to make these modifications, add environment variables, deploy out specific code packages, make modifications to whatever scripts. Well, if you automate these processes, if you automate that deployment, then if I need to do it again, it's push a button or run a script and the new server is out. So I don't have to think about this special server that I need to do all of these extra things to get it to run. My servers are just homogeneous blobs of processing. And the good news is, like Anders mentions here, you know what? You lose a server at 11:42, it's back up by 12:10. Sometimes it's even quicker. But you can't do that if you have so much manual effort to get a server running. If you have to manually install Windows, install updates, configure networking, configure file servers, configure file shares, deploy out code, make those hand modifications to all of this stuff, you could be talking being down hours or days versus here's a couple minutes. Half of that was waiting for somebody's login to be elevated to redeploy. There you go. And when you talk about more advanced operations with systems like Kubernetes, you can even get things configured to where this server does not exist. We don't have enough of this server up. Let's bring something else up. Something is failing. Cool. Kill it. Bring up a new one. Because everything is scripted out. They're all homogeneous blobs of compute. And speaking of Kubernetes, we did have Andrew Prusky. I always remember after I say his name out loud that it's Prusky and not Prusky. And Andrew is too polite ever to correct me. So I have all of these bad habits in my head because I know that it's Prusky. And then it'll just slip out the wrong way and he'll just go on with it as though nothing happened. But he presented for us last Tuesday, in case you haven't seen that recording, and did cover the idea of Kubernetes and Helm, including with SQL Server. As you get to these types of automation strategies, life gets to be a lot easier to where if something does fail, it's real easy to bring it back up. It's real easy to get things going again. There are things that are tougher to automate. You may have bespoke processes that are specific to a single instance of a SQL Server. Like, for example, this one has machine learning services installed. This one has something else, distributed replay. Rest in peace, distributed replay. That's not making it to the 2022 cut. But you have special things that are maybe only installed on one instance or a few instances, and that can complicate those deployment scripts a bit. But putting the time into the development effort to automate those deployments, to automate server processing, really pays off in the long run.
Amen to that. 100%.
And in case you're not sure, what that process looks like, if you're living in the you're in the data platform world, specifically SQL Server, I would recommend checking out DBA Tools first, dbatools.io, because they have a lot of great processes. I'm just typing out the address so that I can make sure I get it right. dbatools.io, a lot of great PowerShell commandlets that help with many operations. I actually set up an automation process for testing database backups, and then rebuilding a QA environment, including, heaven forfend, merge replication. And got the whole process scripted out. There's about 2 steps of manual effort, and most of that is basically sit here, wait for this to finish, and then continue the script.
They
Because
have a wonderful book too, a book by Manning Publications. I posted the link there. It's worth purchasing and going through a little bit of a time, a little bit at a time. You can learn it, and it's a good way to learn PowerShell too. If you're not very familiar with PowerShell as a scripting language, the DBA tools is the best way to learn it.
Yes, it is. That is a fantastic book. I have a copy of it here. My copy did get a little roughed up in the mail, but I read probably about half of it already as part of the Manning Early Access program. And Christy Lemaire had some Twitch streams where she was going through the book structure, where she was going through some of the chapters. So that was entertaining to watch. Merge replication.
I missed that, Kevin.
Yeah, this was a while back. This was sometime, I think it was in the winter. But she had a few streams. Merge replication, Kevin's favorite technology. I will not admit on my resume that I know anything about merge replication. And there is enough that is just black magic that just does not need to be. Things that really should be made very straightforward and obvious to people, that is hidden behind undocumented merge replication tables or stored procedures that are 90 characters long in terms of the name and have obtuse parameters. Yeah, it definitely needs some love. And given that, your joke is pretty much true, transactional replication has gotten a little bit of development work over the past decade. Merge replication has got just enough to make sure that it's still relevant in the SQL Server, the newest versions of SQL Server. So there are small changes that happen, but that UI, that's still from 2005 maybe. The RepelMon. I don't think it's fundamentally changed. It is useful. It is very useful. It would be more useful if you could get documentation without begging Chris Skorlinski or Hillary Cotter to answer a thing for you. And those two are outstanding gentlemen, very upstanding individuals. But if you need to ask one of those two people to help diagnose why is there this problem because merge replication doesn't give you enough information otherwise, you're like, oh, error -276,809. Yeah, everybody, by which I mean two people, know that means that you have to do this thing with the snapshot. And all of these things that are just barely documented. Just make it easier. Get a UI that's straightforward. Get a UI that's understandable. Spend some time on making it more robust. Spend some time making it just useful to people. And one of the biggest pain points in merge replication is you cannot tell. You can kind of tell how far behind am I. You cannot tell when should I expect to catch up. My subscriber is behind. You can tell that you are behind. You can tell for merge replication. For transactional replication, you can actually get decent information by saying, oh, here are how many transactions are yet to perform. And you can get some feeling for how far behind you are and a rough idea of how long it's going to take you to catch up. Merge, the tables are there, but you have to really dig in to understand what items still need to be processed. So it could be much better. It is definitely a useful technology, as much as I am loath to admit it out loud, because I don't want to get saddled with merge replication projects. But I think it is a useful technology. I think it's if when it's working, it's actually impressive to see that, hey, we have a dozen different machines that are all working together, transferring data. Everything's going great. If you've architected it well, if you've designed it well. I mean, Anders' scenario was, what was it? Thousands of servers interacting. You can have absurd levels of scale out using merge replication and have it work pretty well. The problem is when things break, they really break. And sometimes they break because of just strange reasons. Like this thing should not happen. For example, dealing with identity integer management, where identity ranges are handled on different servers in your merge topology. So server A may have IDs 1 to 10,000 and 10,001 to 20,000. Server B may have IDs 80,000 to 90,000 and 90,000 to 100,000. Server C may have this other range. And as they overlap, technically they're not ever supposed to overlap. Technically is a fun word. Just dealing with messes. Basically, if you're going to do a new merge topology today, I would probably say either don't use identity integers or don't use identity integers as your sole key. Have server name, have customer ID, have whatever is unique to that machine, and just have it be the key part of your customer key. And then don't care about uniqueness of identity integers, because managing identity integers is a real pain when you have distributing IDs across in servers. Even if n is a small number, it's still a pain. So cross server identity management, bad idea. Do not recommend. So 120 servers, but it doubled in 5 years after we went live. No idea what they're at now. That's a good question. All the records were inserted into a main node. Everything else was updates. That does help. When you have a fixed flow of how things go in and how things operate, it reduces the likelihood of merge conflicts. Merge conflicts can still be a mess. It's something that I've had to deal with far too often. And again, my experience is the best way to fix merge conflicts or to prevent merge conflicts is to have something that is unique to the machine that is accepting the write, so that you don't have two servers trying to accept the same write. And so that might be if breaking out replication nodes by customer, or breaking it out by region, or breaking it out some way such that if I'm going to write this record, I'm only writing this record at this location. I'm not going to try to write this record and here and also here, because as soon as you allow that, it's going to happen. People are going to have collisions. Merge replication does not deal with collisions that well. It does have capabilities, but again, this is something that tends to be buried. And the conflict resolution tool that they have, I don't know that it's been updated this decade or the past decade. So I think it's probably been about 15 years since that tool got any love. So there's pain. There's pain. And it's not the good kind of pain. So let's talk about partial containment. This comes in from friend of the show, Mark Gordon. Not sure if Mark is in chat tonight. Did not see him so far, but that's cool. So Mark sent an email, was asking about partial containment because I guess they're working on something that requires containment. And when a contained database is enabled, they were reading that database users with the alter any user permission, like members of DB owner or DB access
So I
admin.
didn't even know people used contained databases, Kevin. It seemed like.
Well, yeah, there's not, because it's partial containment and they only introduced it in 2012 and they never really did anything since 2012.
Right.
Most people don't use it except if you're using Azure. So Azure SQL Database extended out that notion of partially contained databases and got to more fully contained. But yeah, this was also the first time that I heard anybody really working with contained databases, but apparently it fit whatever use case that Mark and company needed to handle. So database users that get alter any user as a permission can grant access to databases, and by doing so, grant accesses to the instance of SQL Server. And the follow-on was that, well, this means that control over access to the servers is no longer limited to members of sysadmin and security admin as fixed server roles, and logins with the server level control server and alter any login permission. So this came from, let me see if I can find the original link. Yep, here it is. So Mark and company were reading this page that I just linked to in chat, and the note was this important note, and I'm going to copy and paste the important note for chat. Oh no, I reached the character limit of 500. So there's the first half of it, and then the second half of it is going to be right here. There we go. So they reached out to me. Well, Mark reached out to me. He was like, hey, this sounds weird because with a partially contained database, when you create a user, even if you say that user is a DB owner, Mark's interpretation was this is sounding like you can connect to the instance and implicitly to other databases, which you can't do with partially contained databases. And so to clear that idea up, what they're saying is, let's say we create a login. We create a login called test1. Test1 is a DB owner of contained DB1. So we have the login, we have the user. The user is a DB owner. Test1, which is our proper login. Test1 has access. Maybe we have Test1 has access to some other databases as well, because it's a regular SQL Server login. So Test1 creates Test2. Test2 is a contained user. So create a user instead of creating a login and then a user based off of that login. Contained user means Test2 is allowed to connect to instance.contained DB1. So we created a contained DB. We granted a new user without a login, the ability to connect to that database, that contained database. So TestDB can connect there, but cannot connect to non-contained DB or contained DB2 on that instance. Test1, if we say Test2 is a DB owner, so Test2 is now a DB owner. They're a DB owner on their contained database. Test2 cannot create Test3, which is a login. So Test2 isn't going to be able to create SQL Server logins. You're not able to bootstrap your way from working within a contained database to working in all databases. Test 2 cannot create a user that's allowed to access a different contained database. So again, you can't bootstrap your way from contained DB1 over to contained DB2. Not possible. Even if test 2 is a DB owner. Test 2 can create test 5. Test 5 is another user on contained DB1. So within the scope of the contained database, you can create new users. You can't create users outside the scope of the contained database if you are a contained database user. You would have to be a SQL Server login or Windows authenticated login or an Azure AD login in order to create additional logins that can access other databases. So what they say, the comment is that you grant access to databases, and by doing so, you grant access to the instance of SQL Server. This is the part that I think was the most confusing, because it sounded like by grant access to the instance that you have broad access. But really what they're saying is you are allowed to connect to instance. You need to connect to instance in order to connect to instance.contained DB1. But just because you can connect to instance does not mean that you can go to instance.msdb, instance.model, instance.contained DB2, etc. You're not granted access to the instance. You are granted access to the instance in as much as you need to connect to the instance in order to be forwarded to the database. The database does not have its own IP address and port. So you have to go through the instance to get to the database. And to that extent, you have connect on the instance, on the server. So you are granted connect, but you're not granted rights to do things outside of the contained database. And outside of master's a special case. It's a weird database. But if you are a contained user, again, using the concepts from partially contained databases versus Azure SQL DB, you're not really able to pivot outside of that contained database. So you don't get broad-based access to the instance. And yeah, Mal, I really don't see anybody using this either. Back in 2012, I thought it was a pretty cool idea. And it's obvious that the idea has taken on form within Microsoft, because we see containment within Azure SQL DB, where you have the ability to create databases, to work within databases, and operate on things. But if you move the database to a new server, will anything need to be done to make it work? The users live with the database itself. So the only thing that, if I remember right, is it's been about a decade since I've used partially contained databases. But if I remember correctly, the only thing that you need to do is update the whatever connection string you're using. So from
Don't
instance
you need to
to
create the
instance
logins
to,
at the server level, Kevin?
nope, that's the idea behind partially contained databases. You create a user without a login. The login lives at the instance. The partially contained user lives within the user database, and that's part of why you can't pivot to another database.
Got it.
So I'm pretty sure, my recollection was that all you needed to do was restore the database to the new instance, and permissions would already be there because you did not need to associate anything with a login. And by authenticating as the user on the database, SQL Server knew that this was a user-based authentication instead of a login-based authentication, and therefore would connect you in. But again, it's been a while since I've played around with them. I never actually used them in production, and so there may have been some oddity to their behavior that I just don't recall at this point. But I thought that was a fairly interesting email from Mark because, yeah, partially contained databases, not a thing we tend to think about very much. And to prep for the 2012 cert, pretty much. Database owner login might need to exist if you want to be consistent between servers. There does have to think about, there does have to be a database owner. So yes, but then SA could be the database owner. That's a real login, not a user without login. Yes, the database owner does have to be a real login. And if you were trying to use partially contained databases, I mean, I don't know that we have many good use cases for it. You might just, yeah, it could be SA, it could be some Windows authenticated domain backslash database owners, and just some Windows authenticated accounts so that you don't have to worry about SQL logins and making sure that between instances the SIDs match up. So even so, I think the only use case I could even imagine for partially contained instances, or excuse me, partially contained databases, yeah, just use containers instead. Yeah, this was a pre-container. I need to have databases and I have some compute and I want to move around databases based on compute, and I don't care about the downtime between backing up from a database from disk, or heaven forfend, you're copying, detaching and reattaching database files. And I just want to have some way of shuffling databases around and have those databases be self-contained pods, which eventually led us to Azure SQL DB, to some of the capabilities there. And I think containers really have taken that use case away. That, I believe, is one of several reasons why we never got any more feedback from Microsoft around partially contained databases. We never got any more, iterations on this. So I do not know the answer to that, Anders. That was no idea. But I assume from the question they may actually be using contained databases, but who knows?
Oh, city. Okay, interesting.
So as we go along, Docker containers did end up taking over in terms of many of those types of use cases where I don't care where this thing is. I want to be able to quickly shuffle it around. Going back to Kubernetes, where I have some capabilities of having a pod that I can instantiate. I can move things, and we just didn't get much in the way of partially contained databases getting to be fully contained, which has happened a lot of times over the past decade or so. We got the beginnings of a feature, never really got the end of a feature, and in many cases the feature just died before ever becoming fully useful. So on that sad note, let's talk about the next topic. And that is, Mala, you've been working with MySQL for a bit. Now, I did promise Mala that I would become the lightning rod here. So that way, Mala can share good information, positive information about her experiences, and I can be the one to say that bad development on MySQL is a chicken and egg problem, in that I don't know if it's MySQL the product or the people who use MySQL who cause the database problems, but they sure seem to go together.
So we have a company that our parent company, the place where Kevin and I work, our parent company has acquired a small company based out of France, and they are into MySQL, and I have been entrusted the job of supporting them. That's how I got into learning some of it. I'm just a week and a half old with it. Just went through. They're still trying to train us on their system and such. Number one thing that I liked was that their entity relationship diagrams are seriously better than what SQL Server has with database diagrams. Like, good stuff for free. So we had about close to 150 tables. That thing really re-engineered it really well. The diagrams are scalable. You can save them in different formats. You can print them really well. So, and it is searchable too. You can, if you want to search for a specific table, it lets you search. So I like that. The first thing I do when I'm handed a database to support is I look to see if there is some kind of relationship diagram I can look at and see what's connected to what and how it's laid out and that kind of stuff. So that part I really liked. I'm learning a few things as I go along. I learned this thing about the engine being different from the language, that it runs on two different engines. So that was the news to me. I didn't know that. SQL Server is not that way. It has its own engine. You always have to use its own engine, which I think is actually a good thing. So, but that's one thing I learned. Then we wrote a few queries, and I found them for the volume of data that it runs pretty slow. So that part I'm not hugely impressed at all. But for a free product, the one license, the one that we are using is free. It's not the paid version, so I don't know if the paid version would be any better. So they told me things like, if you run a backup, then you cannot run a query at the same time. Okay, so okay, things like that. So we are learning as we go along. That's bits and pieces of things that I know.
Yeah, so I just dropped a link in chat to the MySQL engines. There are a lot of them. It is interesting to see the engines changing over time. I'm pretty familiar with InnoDB, and I'm sure I'm familiar with one other, but I can't remember off the top of my head. Maybe it was MyISAM. But MySQL is a pretty solid product. If you're going to ask me open source, choose a database platform, it's going to be Postgres. I think my jokes aside, caustic joking aside, MySQL can be a very useful platform. Certainly the price is right there. Well, unless you're on Oracle, in which case you use MariaDB, because then the price is even better, because you don't have to sell your soul to Oracle. But it is still a place that has the good of, it's an easy way for developers to get started working with relational databases, but the bad of, by making it intentionally easy for developers to get started, they really encourage bad habits, which lead to really bad code, leading to poor performance given the relative power of a machine. You can certainly do very well in MySQL. You can have powerful servers processing very large numbers of transactions per second. So this isn't some sort of performance measuring contest of, well, your database engine's slower than my database engine. It's not really about that. It's instead that quite often when you're working with a MySQL database, you are working around problems that people have had. And there is a lot of this in the SQL Server community as well, because, hey, it's easy to create a table. I have this UI that lets me create tables. And then I created all these tables, and I'll create some views. And look how easy it is to nest views. And 8 views later, why is performance so bad? And the reason is that your data model was drawn by an 8-year-old. Cough access. Exactly. I was actually going to get to access that. A lot of people who are SQL Server developers are really access developers in disguise that have never thought about concurrency or, multiple users of a database. And as a result, do not write things in ways that think about performance or long-term sustainability or even quality of data. 30 users in an Access database. Actually, that might get you an award. So Solomon on the previous topic says partially contained databases seem only to exist to be interchangeable with Azure SQL DB. I think what I would rephrase that as is what happened with Azure SQL DB was built upon the work that was done for partially contained databases. So the partially contained DBs came out, if I remember right around the time Azure SQL DB was switching to version 11, maybe it was V12. It was right around that time where they were either in the second to last or the last switched version. And the containment concept was something that they needed internally. They exposed it as a feature in SQL Server, and that might have been to try to convince you to switch over to Azure SQL DB, perhaps. But I think it was more they needed to do the development effort internally, decided to turn it into a feature, didn't get much in the way of positive feedback on, yes, this is really useful to us, in part because for a lot of companies it's not useful, and in part for the companies where it is useful, they didn't finish the job, and you ended up in this terrible pit of development disaster where I have this job that's halfway finished. It's not far enough along that the people who really need it can use it, and it's far enough along that, well, we've invested a lot, so for further development we need to see people adopting it. Yeah, but you're not going to adopt it until you've actually finished it. So nobody adopts it, and therefore it just kind of dies off. I mean, there are at least a dozen of those cases over the past decade in different versions of SQL Server. In-memory OLTP is one of them. Polybase is one of them. Polybase did get a second update in 2019, and that improved it, but still a lot that I would like to see done there. Distributed replay, extended events for about 2 versions of SQL Server. Fortunately, they did extend that out. They did extend Query Store out, but for things where you didn't get an immediate massive takeoff, it was like, oh, well, we'll make this better when more people use it. But people aren't going to use it until it's better. And this is the frustrating part about interacting with the program managers, because it's not that the program managers don't hear any of this stuff. And I think they certainly do hear from it from people. But I understand that the team has to balance doing things that people want and putting out the things that enough people are going to want that will make them buy SQL Server and keep SQL Server. And so having to make decisions across what are the 9,000 different things that people want and trying to pick the 5 to 10 that are most impactful. So I understand the pain that they experience, and don't want to sound like I'm being too harsh on them. At the same time, when you deliver half-finished products, you're not going to get half of the support. You know, this isn't a linear growth thing where, well, if I give you a quarter of the product, I'll get a quarter of the total populace using it. This is instead something that's more like a flat, eventually exponential curve, where if you give me 0% of the product, you'll get 0% of the takeoff. And if you give me 50%, you might get like 2% of people. You have to give me about 95% before you really see that curve take off. Because we need that functionality. Like if you solve half of my problem, I still have half of the problem. So now why am I going to invest the time that it takes me to build something to have the other half of the problem still be there? Or 80% with the faith that the rest is coming. Yeah, if that was clear, like I think Query Store is probably a good example of this, where Query Store came out with Microsoft explicitly saying, we are going to continue supporting this and expanding it. Or extended events, where Microsoft clearly came out and said, this is the way forward for determining measures, determining data points in SQL Server. So in those cases, you knew that they were committed. And even in 2008 with extended events, that they weren't really adding new profiler events. These were all coming in as extended events. So, or server-side trace events. These are all coming in as extended events. And therefore, even though the UI was non-existent, the interactions were painful, the mechanisms were fairly simplistic, you had to shred XML yourself, and it wasn't a very good experience. Even with that, you still knew that this was going to be fully supported going forward. So yeah, in that case, I think you can, if you know that the rest is coming, it makes sense as a user to potentially adopt. But in many of these cases, we're not getting 80%. Like in-memory OLTP, we got, 20% of what it could do. And within that realm, if you lived in the use case of that 20%, yeah, it's a cool product. Now, part of the problem was people misunderstood that in-memory OLTP does not make reads faster. It makes writes faster. It doesn't do anything for reads. Your reads are already in memory. That's kind of, the buffer pool is memory. This is like Charlton Heston. Buffer pool is memory. Buffer pool is memory.
Good one, Kevin. I like that.
But you know what? If you lived in a place where you needed extreme write performance, in-memory OLTP, memory optimized tables actually do a really good job there. Delayed durability actually can help you there, especially if you have a process where you can reprocess on failure. And the problem is that's a small percentage point. Because for the companies that need that, we also have cross-database joins. We also have things that you look at and say, oh, well, we use data types that you're not supporting. We use these strategies that you're not going to support. We use these features of T-SQL syntax that you're not going to support. And because of that, we can't adopt your product. That we would be a perfect use case for in-memory OLTP for scenarios A, B, C, and D. We can't do it because we have cross-database joins. And as a result, we're not using in-memory OLTP. That's the use of, that's the what you hear from a lot of companies. A lot of people, smart people working at companies who have seriously investigated this, wanted to use it, said, if you gave me the full product, I could use it. I could make great use of it. But we don't get the full product. They don't use it. The full product never comes out because nobody's using it. Yeah, nobody's using it because you never gave us a product that we could actually use. You gave us a tech demo.
That was actually intended as a computer for SAP HANA, and that went a different way. So I suppose they didn't evolve it beyond that.
Yeah, that could be. That could be.
So it was rolled out in a rush to compete with that.
Yeah. And I know that memory optimized tables, the whole in-memory OLTP concept could have been amazing. And had the potential. There were tough technical problems that they needed to solve. They never got the chance to solve them. And as a result, this is going to be a niche product forever. I don't think in-memory OLTP's gotten a real update since 2017. And I didn't hear anything about it in 2022 so far, so I'm not sure there's going to be anything there. There might be. Between the first CTP and GA, they usually sneak in a couple more things. So I don't know if there's going to be anything there or not, but this does feel like a product that is just going to be there. That it will not be removed. It just won't be improved. So let's see. Going back to chat. Contain DBs. Nothing more than marketing. One large company wanted it. There probably were a couple more. There were at least a few companies that wanted it. But yeah, you're right. I think it was more of, I have a few large companies that would legitimately meet this use case. They did just enough so that those few companies that they were talking to could meet their exact use cases. And then for everybody else, it was, it's there if you want it. But then people would say, I don't see how I can use this meaningfully. Going back to MySQL, the harder you make performance, the harder you make it for developers, the better your performance you get. Spoken like a true.
Sure about that, maybe.
I was gonna say, spoken like a true Oracle DBA.
Yeah.
Where I'm pretty sure they have wizard robes. They meet in darkened alcoves. They speak in tongues. That's just so that nobody else can understand what crazy code they're writing. Andrew says, man, I've barely embraced DMVs. I don't know, that's fine. It's fine. And too many meetings with Kellen Povan Gorman over the past 3 years. Kellen's good people. Actually, we were talking about her in the pre-show and about indexing strategies between SQL Server and Oracle. There was a talk she gave for TriPass. It's got to be 3 years ago at this point, and where she talked about how going back to storage engines, the storage engines differ between these different platforms, and information that you know about one platform at that level doesn't help you at all in the other one. So if you know a lot about InnoDB, switching over to SQL Server and its database engine, it's a whole new story. And then switching over to Oracle and its engines, completely different story. And we're not even talking about things like Exadata. This is just the base engine for Oracle. And by the way, one other comment in here, MySQL was started by Swedes, and possibly the only thing worse than software written by Finns. And I am here to white knight for Erlang, because that is an amazing language. In case you're not familiar with it, Erlang is a functional programming language that runs the Finnish telephone company. And it's the type of language where they embraced self-healing to the point where machines can go down, things can fail, entire processes can just be obliterated, and the thing still keeps working because they designed it explicitly with failure in mind, with routability in mind, and it's down to the core concepts of the language itself. Where with functional languages, because you're not sharing state, you're passing data, and one of the nice benefits of this is, because you're passing data, if your machine blows up, that's okay. Whoever passed you the data can send it to another machine. And you can easily route things around. You can treat things as functions operating data and end up with an extremely robust system where you don't have constant failure because one node went down. And that's a similar concept to 2 decades, 3 decades later with Hadoop. And the concept of, oh, one of your servers failed because you have some garbage off the shelf servers that you bought at a garage sale from businesses going out of business, companies going out of business, and you just slapped a bunch of disks in there and hoped that everything would go right, and server failed. Hey, no problem. Let's use a different server instead. As long as you've got enough servers to keep going, failure is fine. So disks die, that's cool. We've got extra copies of the data. Just slap another disk in there. We'll start moving data over to it. Servers fail, hey, that's fine. We'll just get another one running in the pool, and we'll take that compute and just work with it. So that concept of consistency and stability in the face of known chaos, that you don't trust that the things around you are going to be successful. You have to be robust enough to handle all the problems that could happen, because they will happen. So yeah, that's and the idea that this is all baked into a programming language is really interesting. It's not a programming language that is easy to use, not by any stretch. But the idea that, this stuff is that you have a software that's capable of doing so many of these things, I just find it amazing. And that's my extended discourse on functional programming for the night. Come back in 2 weeks for another extended discourse on functional programming here on Functional Programming Talk. Oh, Anders, don't worry. These are Finns. These aren't Swedes. So, also, there is that Torvalds guy. I don't. Not sure if we trust him either, but he's Finnish too. But yeah, the Swedes. Oh, they're a unsavory bunch. Oh, I hate Git. You're right, Andrews. I loathe Git. I despise the fact that Git became the standard, because it is really painful if you are not a maintainer of the Linux kernel. It is unnecessarily painful for about 99.9% of developers across the world. And it is almost like they revel in the sadistic pain that they cause people when, oh, don't worry, git reset hard -2, everything's fine. we're just gonna rebase, cherry pick, and deal with all these other problems. Mercurial was so much better of a platform, but that's the way she goes. Sometimes she goes, sometimes she doesn't go. She didn't go. That's the way she goes. So this episode of Trailer Park Boys brought to you by Triangle Area SQL Server User Group. Remember, next episode of Shop Talk, 2 weeks from now, 2 weeks from Monday, VSS for DBAs. Visual Source Safe is fine if you're doing this for yourself. As soon as you introduce a second person onto a project, it's you're going to lock each other out, and then you go on vacation and the other person can't get any work done. And so I guess, yeah. If you don't anticipate ever going on vacation, you did say DBAs, so technically going on vacation is a bit outside the norm. But remember, tomorrow we have our main meeting, asking the right questions, getting through imposter syndrome. So Sam Hetchler is going to talk to us about that. Next Tuesday, I'm going to be out of town, but we're still doing TriPass. We're going to talk about topic modeling made easy. So we've got quite a bit to go for the month of July. 2 more meetings. And then I think I have to remember what day the 31st is, but I believe the 31st is a Sunday, so I think the next shop talk is going to be in August. Warm, cuddly memories around VSS. Storing all your Fox Pro databases in there.
You
So with
remember SQL multi-script. Good memories.
huh,
That's how we used to deploy.
there you go. Anders is going to go be a farmer, and after all those months of playing Farming Simulator,
Not a bad idea at all, man. Not a bad idea.
Farming Simulator just keeps him honed for the season when he goes back and helps on the farm. So you gotta keep those skills fresh. And with that, we're gonna wrap up for the night. So we'll see you again. Hopefully we see you tomorrow. But next time we do see you, be glad to. And until then, take care.
Bye.